morning students. Today we learn about voltage to current converter. So voltage to current converter is a circuit which converts the given input voltage into its equivalent output current. First let us understand what is the need for a voltage to current converter. So in many of the industry applications we need to transfer a sensing parameter from one end to the other controlling device or to any display device. So in that case, if you transfer the sensing parameter in terms of voltage, there will be a potential drop and it is prone to noise also. So in that case, we need to convert that voltage into current. In that, so for those applications, we will use the voltage to current converter, which converts that voltage into current, and when it is transmitted in terms of current, it is less prone to noise. Hence, we prefer to connect a voltage to current converter for industrial applications. So let us now learn about voltage to current converter for two types of loads. One is with the floating load, the other one with the grounded load. So first let's learn about floating load. This is the circuit where the load is, you can see it is a floating load Vto I converter. You can see here this is the load which we have connected us. So this is a circuit for a floating load Vto I converter. So you can see here the input is given to the non-inverting terminal. Since you have a negative feedback, you have virtual short. You know the concept of a virtual short. So whatever the voltage is presented here will be presented in this node also. So here the voltage will be VA. Applying KCL at this node. Let us consider this. Let us assume this node to be A. Applying KCL in this node, we get I is equal to KCL. I is equal to IL. So what is I? I is nothing but V input divided by R, which is equal to IL. So here the R is a constant value. So whenever from this expression we understand that the input voltage is proportional to the load current IL. So this is how voltage is converted into its equivalent current. Next, let us move on to, I hope you understand this floating load Vto I converter. Next, let us move on to grounded load Vto I converter. So students, now let us discuss about grounded load Vto I converter. So this is a circuit. Can you see here the load is grounded over here. Okay, please take down the circuit. Assume voltage V1 at node A. Applying KCL at node A. So now let's apply KCL at node A. At node A, I1 plus I2 is equal to IL. Okay, can you see here I1 plus I2 is equal to IL. Now let us write what is I1. I1 is equal to V in minus V1 by R. V in minus V1 by R. And I2, what is I2? I2 is V0 minus V1 by R is equal to IL. So on simplification we get Vn. Since both the denominators are same, we can bring the denominator to that side. So Vn minus 2V1 plus V0 is equal to IL into R. Mark this as equation 1. Mark this as equation 1. Now let's move on to the basic concept of a non-inverting. Now let us write the output voltage equation of a non-inverting amplifier. So this is a non-inverting amplifier. Can you see here the input voltage is fed to the non-inverting input. So I will write here the output voltage of a non-inverting amplifier V0 is equal to, as you have studied already, V0 is equal to 1 plus Rf by R1 into V1, because the input voltage we are giving here is V1. Here Rf is the feedback resistance and R1 is the input resistance. So this Rf is equal to R and R1 is equal to R. I am substituting here. So you get 1 plus R by R into V1. So now your V0 becomes, so what happens, R by RR gets cancelled, so it will be 1, so it is 2V1. So from this expression we understand that V0 is equal to, so now I'll write this. I'll write this one. We have come to the conclusion. So V0 is equal to 2V1. Mark this as equation 2. Substitute. Sorry. Mark this as equation 2. So mark this as equation 2. So the equation 1 substitute. Equation 2 in equation 1. V0 is equal to IL into R. Substituting V0 is equal to 2V1. I am going to substitute here. So it becomes V1 minus 2V1 plus 2V1 is equal to IL into R. So these two gets cancelled. We get VL is equal to IL into R. So here R is a constant value. Hence whatever the input voltage is directly proportional to the load current. So from this we understand that if the input voltage is varying equivalently, the output load current will also get varied. Hope you understood this lecture. If you have any doubts, you can get it clarified. Thank you all.